Greetings, it's Robot Tony, or Larson Scanner Shade Tony from Adafruit, and I'm sporting this cool little project that I built in the last video stream. So I think it was 2 days ago, so Sunday, I built these glasses, really cool sunglasses that have a strip of neopixels in them that move back and forth. And we call them Larson Scanner Shades, named after Glenn Larson, who is the producer of Battlestar Galactica and Knight Rider, two really cool sci-fi shows that had this really iconic sweeping animation like that. So these work great with glasses. And I'll put a link in the description below when this is up on YouTube if you want to go check out the first video where I just show how to build these. But during the build, I kind of ran out of time. I wanted to enhance these a little bit and add a button to the side. So you can see right here, this is a Gemma that powers it. And a little bit further back right here, I've actually put a button on here that doesn't do anything yet. Let's see if I can kind of figure out where it's at. It's hard to see through these glasses and actually see the computer monitor. But that's what I wanted to do in this video stream, is look at adding the functionality for the switch that I added to these glasses, because I want to be able to change the color. So if I press the switch, I want to change from red to maybe like blue or green or, different cool colors to cycle through them, because just by default, the simple Larson scanner is just built to use one color. And so if you want to change the color, you have to reprogram it, connect it to your computer and get started there. So I figured in this stream, we'll just start hacking on this. I've made a few changes since the last stream that I did on this, and I'll kind of go over those first. And then we'll just dig into looking at the code, and I'll walk through the code for the Larson Scanner sketch to just kind of show you how it works. It's really simple and straightforward, and then see how we can make some small little tweaks to add in maybe like a list of colors and then cycling through those colors for this. But that's basically the project. So of course, you've got to have a nice striker pose here with it look like a robot. I'm building these for Tour Camp, which is happening this week. It's this really cool little hacker camp in Washington State. So let's just kind of dive in. I'll jump to the desktop view and turn everything else on. So let's do that. And then unfortunately, let me take these shades off because they are super cool, but we need to hack on them for this project here. So let's see, I'm going to pull the battery out of these, and I'll show you the changes that I made to it real quick also in just a second. All right, pull that off. And so in the workbench, and here maybe we'll let's jump just straight to workbench view. Turn that off. Yeah, I'll put me down here. So here the glasses are right here. Well, actually, you probably won't even see my face here, so I'll turn that off since I have to move over. And I'll just run through the changes that I made to these glasses. So, the basic glasses, just like what I built in the last stream, you can kind of see here, they're really cool mirrored sunglasses, kind of, one big unibody kind of look to it, real neat futuristic style. And then to the side here, I hot glued on a Gemma board. And then inside of it, it's a little hard to see, but there's actually a strip of mini neopixels here that goes across the whole length of the glasses and then points out towards the front of them. And since the last stream, so you kind of saw I ran into some fun where I wanted to use the silicone kind of cover here that allows you to protect the neopixels. I wanted to glue that into the frame of the glasses and then let the pixels sit inside of there. But I had some fun because hot glue doesn't really stick to silicone, and someone in the comments had a great suggestion that really the only thing that sticks to silicone is silicone itself, so you need a silicone-based adhesive. So maybe you could get like a silicone RTV or something like, a gasket maker or something like that. That would probably work to do this, but I ended up just hot gluing the raw strip of pixels right to the glasses, and that's fine. And then I put a little strip of electrical tape over the back of it just to cover up. It has some exposed pads, so I wanted to cover those up so that they couldn't get like a lot of moisture and stuff. I wouldn't call this weatherproof. This is not safe to take into a downpour, and unfortunately it looks like this weekend there might be some rain, so this might get limited use, but we'll see. But anyway, so yeah, I connected the strip pixels. I hot glued the Gemma onto here, and then I soldered up just some small little wires here to connect the neopixels to the Gemma. And then another little tip that someone in the comments also mentioned that would have made a lot more sense, glue the wires first and then hot glue the whole board down, because I glued the board down and then it's tough to get the wires. You could wrap the wires around the little holes inside there, but I couldn't really do that because it's glued down. So, think through how you're going to build things before you start hacking on them sometimes. Now, one difference, I added this little button right here just a moment ago. I just hot glued a little push button on there, a little 6mm slim tactile switch. It really just has two sides to it, and whenever you press it, it connects both those sides. And the way I've wired this up to the Gemma, I have one side going down to the D0 input down here, so just a digital input, and then the other side is going to ground right here. And then if I configure Gemma to read the D0 input as an input with the pull-up resistor enabled, then normally it's going to sit at a high logic level, and when I press the switch, it's going to get pulled down to a ground or a low logic level, and I'll be able to detect that as a button press. So real easy way. I don't have to add like extra resistors and stuff. It's just all built in there for it and ready to go. And then the way I oriented this also, so the battery plugs in on this side with the JST connector, and like I was showing last stream, I just have this little 500 milliamp battery. Since the last stream, I just covered it in gaffer tape, so it's just like a cloth tape, real nice handy tape to have, just to give it a little bit of extra protection. And because it's going to sit against my head, it kind of hangs down like an earring like this, then you know it's a little bit softer and nicer than just the raw battery cell. So that was really the only change that I made. And then the front here is where I can plug in to my computer here to program Gemma, and that's actually what I'm going to do. So I'm just going to plug in the Gemma with the USB cable, and then make sure to turn it on. So Gemma, the V2 Gemmas have a little on-off switch, so make sure to turn that on. And it goes into the bootloader, so it's going to flash that a little bit initially. And you might see like the pixels lit up, you know, weird little colors. And that's just because their input pin is like floating and they can get kind of weird noise. But once the bootloader stops, you see it jumps right into its sketch. So, okay, let's see. I'll see if I can have the glasses kind of facing up so that you can see as we kind of program these how it changes. So let's see, maybe I need to prop this up with something. Grab a multimeter. That works. That's not too bad. Put that a little more centered there. So, okay, there's that. And then let me just quickly change the battery on this light that keeps dying for some reason, but I got a fresh one, so I'll put this in. Oops. Yep, make sure that's the right way. And, alrighty, let's switch back to the main view here. So, okay, cool. So, I've got on the web browser here the project that I built, the Larson scanner shades that Phil B did. And so, you know, go back to the previous video, you can see I did a full build of it. Somebody move the microphone back to point at me. And, you know, you can see how I walked through and put it together. Pretty straightforward project. Like I said before, don't do this as your very first project. You know, do a little bit of soldering first, you know, learn what an Arduino is, how to program a Gemma, stuff like that. Then dive into something like this. You know, it's not super advanced, but you might get really frustrated if you've never soldered like little things before. So, you know, the last video I did all the wiring and soldering, put it together. The software for this project, really straightforward. You just need to install the NeoPixel library, which is really easy these days. You can use the library manager in Arduino and install that. And then the sketch is actually just included right in the guide right here. So that's what I pulled out and was using directly is the sketch that Phil B did. And so that's what I have right here in the Arduino IDE. So, and I made a few little tweaks. I changed the number of LEDs and the pin that I'm connected to. So I'm using pin 1 on the Gemma, and then I have 8 LEDs connected to this because I'm using a less dense strip. I'm using the 60 pixels per meter. There's a 30 pixels per meter, which is even less dense, and then like 144 pixels, which is, whoa, pretty crazy and intense. I kind of picked it in the middle. You know, you could go either way with this for it. So, okay, cool. So here's the sketch. Now, the one thing I wanted to do first was just test out the button and make sure the button works. And so what I was going to do is let's just grab the basic, the digital, the button example in the Arduino IDE, and we'll just run this real simple little example. So the button, I have it connected to pin 0, and then the sketch works by it'll turn on an LED or turn it off when the button's pressed. And so I'm going to say pin 1 because there's actually an LED connected to Gemma. If we look at Gemma, let me move that aside. So you can kind of see there's this red LED that's kind of half lit right now, and that's because that pin is also shared, or at least that LED is also shared with the D1 pin that I'm using as the output to my NeoPixels. So there's this really fast little signal that's being sent to the NeoPixels to change their colors, and then that also just happens to change that LED color. So, you know, it's kind of PWMing that LED in a weird way, which is fine. It's not going to hurt it, but that's why you see it in a weird way like that. Okay, so let's just take this sketch, let's compile it, and I've got it all set up. It should be ready to program with Gemma, but I'm just going to double check. So I've got the board, Gemma, port. You don't need to really select the port. You do need to make sure you have USB Tiny ISP selected, because this programmer works in a slightly different way. It doesn't show up as like a serial port on your computer normally. So, okay, and then what I'm going to do is I'm going to press the button on Gemma, and now the light starts pulsing, so it's in the bootloader, and then I'll hit the upload button, and so that's going to find the little USB Tiny ISP programmer, and it does its thing. And okay, so it just programmed it. And so now the way it's working, oh, and sorry, there's one little change I need to make to this sketch. So this sketch is configuring the button just as a pure digital input, which means you're going to have some resistor like external to this, to the Arduino, pulling it up or down to a high or low logic level, depending on how you want to configure this button. I don't have that, but luckily with Arduino, you can just say, I want this as an input with a pull-up resistor. So I forgot, I need to make that change. So let's re-upload this. Because if I didn't do this, the button, the input is kind of floating right now. And so it's, you know, it might happen to get pulled down to a low level, or maybe, it, you know, the random capacitance pulls it up to a higher level. So that's, you know, you'll get really weird intermittent behavior if you have your pull-ups and things not correctly set. Okay, so now notice the light turns on, and in the loop, basically, if the button is high, if it's at a high logic level, then it turns on the LED. And that's actually what I want to see. Like, it might sound kind of the reverse of what you'd expect, but remember, I have this set with an input pull-up resistor. So normally, if the button is not pressed, the pull-up resistor is going to pull it up to a high logic level, and so then, you know, this part of the if is going to evaluate to true, and it's going to turn on the LED. Now when I press the button, that's going to connect it to ground, and that should pull it down to a low logic level. So let's see, hey, look at that. So I press it, and the red light goes off on here. So that's cool. So we're just checking, you know, basics. The LED or the button works. So I know if I start integrating it into the Larson scanner sketch, it should work, which is always smart to do. Like, you know, test things in isolation before you start diving into something, because when you start running into bugs and you've got your code and you're not really sure, like, what part of the code, you know, is it what you changed or is it something else, then, you know, that's going to help a lot. So, okay, let's get into the code here then, excuse me, for the sketch. So maybe I'll just run through first, and let's reprogram it just to get it back into the kind of default state, or show the Larson scanner sketch. So I'm just going to upload it, and then you'll hopefully see in a second here, after it uploads, that it should start. Oh, that's weird. Why did it not start running here? Huh, interesting. So the pixels aren't lighting up. Let me just double check here. Wow, we might be troubleshooting more stuff than I expected here. So, okay, let's try re-uploading. Oh, there we go. Oh, wow. Okay, so I must have a flaky connection, because I just kind of moved things around a little bit and it just started to come back. So I'll come back to this. I think we'll be okay, but that's interesting. It's good to test things out and see if all the connections are solid. So it could be flaky connection. The other thing is maybe the power from my USB. I just have it hooked to my computer. I don't have a lot of pixels lit up, so I can't imagine it's pulling a lot of power. So maybe I'll come back to that. We'll see if this keeps giving me some flakiness. As you saw in the last stream, you know, it wasn't really the prettiest soldering, so maybe there could be some issues there. But anyways, let's just kind of look through the code for this sketch and just see how it works real quick, and then I'll show you how I'm thinking we can modify this. So, you know, initially it just creates the NeoPixel strip, which this is just a real basic thing you have to do to use NeoPixels. You create this NeoPixel object. It needs to know the number of pixels, the pin that they're connected to, and then this type of pixel. So there are lots of different types. Some of them operate at like 800 kilohertz or 400 kilohertz. Some of them are green, red, blue, or some are RGB. So there's lots of different orders. The most common is the green, red, blue, and then 800 kilohertz. So, you know, that's just kind of the standard thing here. And it's nice to set these as defines in the sketch, so it's a little easier to find these and change these. And then in the setup, all we really do is just initialize the NeoPixel strip. You know, that just sets aside some memory so that it can store all the pixels in a buffer, basically. It has a couple global variables it keeps, so there's a position and a direction. And so the position says, okay, like which pixel is the eye of this animation? Because the way the animation works, there's really 5 pixels that are lit up. So the center one is kind of the eye, and that's maybe the brightest pixel. And then there are 2 pixels off to each side that gets a little bit lighter in color. And then if you move that eye across, like you can see here, it gives you that cool scanning effect. And so that's why you see, more than 1 pixel lit up. And it's kind of trying to emulate, like an incandescent light or something where it lights up and then it turns off, but it takes it a second for the light to kind of fade away. So that's what's happening there with it. So this state basically keeps track of, okay, where is that eye? And the direction is kind of like, which way is it moving? Is it moving left or right, basically, in this case? So then in the loop, really what we do here is we say, okay, let's draw the 5 pixels. So you can see here, the center pixel is kind of the eye, and that gets drawn at the position of the eye, that position variable. And then the color here is just kind of hard-coded. So it says, this is like red with a little bit of green in there. So I think that kind of makes like a yellowish, orangish red color. And then next to the eye, the center of the eye, 1 position below and 1 position above, we do just a darker red, less intensity. So, the way these colors work, it's there are 3 bytes. So this first byte here is red, this is the green component, and this is the blue component. And these are hexadecimal values from 0 to FF, so 0 to 255, where FF is like full red intensity. 80 is like, moderately red intensity. 10 is very low red intensity for this. So that's kind of what you can see here, and you can change these to any other values. But that's the basics, so we do, the center position brightest, the position 1 above and below a little less bright, and then the position 2 above and below, these lines up here and down here, they go even lower brightness, so dark red, basically. Then after we set the pixels, you have to call show, which actually writes out the pixel color to the strip there. And then we delay for a little bit, so that's just, if I didn't have this delay, the thing would just happen so fast you wouldn't even be able to see it. So you give a little bit of time, and that controls the speed of the animation, basically. So if I want to change the speed, I should really kind of change the delay here for it. And then let's see, so there is a little bit of interesting stuff that happens in the sketch here. So let's see, it's erasing all of the pixels. Well, let's see, we'll read the comments. So rather than being sneaky and erasing just the tail pixel, it's easier to erase it all and draw a new one next frame. So it looks like this is going, let's see what this is doing. So we're looping from -2 to 2, and we're going from, so we're basically going through and we're erasing all the pixels. I see, okay, so we're going through, after we draw the pixels and delay, then we basically go through and just erase all the pixels. So we set them all to 0, it looks like. So we turn them all off, which makes sense, so that I guess we don't have to keep track of like, which way was I moving and where was the tail pixel, because when I move another position, if I didn't erase all the old pixels, that last pixel would have stayed lit up. And then the code would be kind of funky because you'd need to know like which direction were you moving, and then how many positions back were you from that to erase it. So that makes sense, I think, to say just wipe out all the pixels. And you could maybe even simplify this more. Since I only have 8 pixels, I could just wipe them all out, just go from 0 to 8 and just set all the pixels to 0. I think we even have a pixel clear, like a strip.clear command you could call, which that would work. But I guess if you have a higher density strip, then that's gonna take a little more time to clear them all out again. So, but that's what that does. Okay, so we clear all the pixels, and then there's a little bit of logic here where we kind of bounce off the ends of this strip. And it looks like, I looked briefly at this, so basically we're saying, okay, so position, we take the current center position and we increase it by the direction. So that kind of means it looks like if the direction is 1, it's going to move to the right, or actually this way since my pixel input is on this side. So if my direction is 1, it's going to move it 1 over that way. And then if the direction is -1, it's going to move it in the opposite direction there. So we basically, that's where we move that center eye. And then it looks like we do a little check and we see, okay, if your position has moved basically past the end of the strip, then we bump it back. So almost like it bounces off the edge. So it goes, from like position 1 to position 0, and then it goes to position -1, and that's when this is going to be true. And once we hit position -1, it says, oh, bounce it back to position 1 over here. And then also swap the direction. So, if we were moving negative, now we're going to move positive in this case. So that's kind of what happens in this block. And then same thing, but basically on the other side here. So when our position reaches the end of the pixels, then we're just going to bounce back to 2 past that. So that kind of makes sense. So it makes it so that if you didn't have that, it would probably be a little bit slower on the ends, because it would come to the end and then it would maybe wait an extra pixel on the end and then come back out. So this is kind of just bouncing off the edges a little bit quicker in this logic. So that's cool. I think that kind of makes sense to do that. And that's all the logic of the sketch, which is cool. Like, you don't need a lot of complexity for this. So that's what the sketch does now. What I was thinking to do to change the color, so instead of hard coding these colors here, I'm thinking I'm going to make an array of colors and then just keep an index into that color array. And every time you press the button, just increment that index so that we're pointing at a different color. And when we get down to the last color, loop back to the beginning there. The one thing that can get tricky though is, because right now the way the animation works, we're kind of saying like, okay, we're just going to assume that you can code in, a bright color, a less bright, and then maybe a dark color. In my case, what I was thinking is I'll just put in my array the brightest color that I want, and then I'll scale that color down a little bit. So I'll take each of the red, green components and divide them by, I don't know, maybe half or like a quarter or something, like maybe a third, something like that, so that they get, less intense. And it's not perfect, like it's not going to change colors, you won't get this nice effect where you have like a slightly orange color in the center, because if my, like I could get that if I made an orange color like this, but then my less bright colors are going to be a less bright orange, which is probably okay. I think it's going to be good enough. An alternative could be I could keep like 2 lists or 3 lists of like, here's the list of the bright color and then the medium color and then the dark color. But that gets a little more complex. I just like the idea of like one list of colors, and if I want to add more colors, just throw an extra color onto that list. It makes it easier to play with these. And then the other thing I think I was going to change is I'm actually going to rip out the positions to like the the last 2 pixels that are lit up. I'm only going to light up 3 pixels because my strip is less dense. And so, with 5 pixels lit up, that's more than half of the strip is lit up at a single time. It's kind of why you see, like, for the most part, you can tell there's an animation, but it doesn't look like it's sweeping as much. So I actually just wanted to start by making that change. And so let's see. Unfortunately, I have to press this button to program it, but let's do that and then program it. And let's see what this looks like. So it's doing its thing. And okay, so now it's lit up. And so yeah, you can kind of tell. Let's see how that looks. It's a little more noticeable, I think. It definitely feels like it's moving a little more in this case. So I think that's cool. I was also thinking that I probably should bump up the delay a bit. Like maybe let's do 50 milliseconds. Just because, again, this sketch was originally for a more dense set of pixels. So, when you have more pixels, it's going to take a little more time to move that position all the way across. So you probably needed a shorter delay. Whereas, I have less pixels. I'm going to move across faster. So I'm going to increase this delay a little bit. So I went from 30 to 50 milliseconds. So let's see if that makes a little bit of a difference. Because it feels a little fast. It's been a long time since I've seen Knight Rider and Battlestar Galactica, but I don't remember the animations being that quick for this. So there we go. That's starting to look a little better. That definitely looks like, a sweeping kind of animation. Okay, so that's cool. So now let's see. Let's make an array of colors here that I'm going to need. So let's just make this as a global variable, and it's a uint32, like an unsigned 32-bit value that I need for this. And we'll just say colors and equals, so this is the array initializer syntax in C++, which is really handy. You can I don't actually have to say how many things are in this array. It'll figure it out and then allocate the right amount of memory on the stack for it. Okay, so here's where I want to put the colors. So let's put each color as just the hex value, and I'll start with the orange color, this super bright kind of color here. And then maybe let's just do, how about, let's just do kind of variations on this 30FF00. I don't even know exactly what colors these are going to be, but hey, we'll see. That's the fun of it. Let's do 30, maybe that. Let's see, how about 30FF? All right, let's see, did I get every permutation of that? I think I did, or pretty close to every permutation for that. Oh, I think there's one more I could do. Oh no, I got that one. Okay, yeah, that looks okay. Let's keep that. Okay, so that'll be our list of colors. And then what I want to do, I need to configure the button. So I need to do pin mode, and let's make this a define. Let's say define button is 0. So pin mode for button is input with a pull-up resistor. And then in my main loop, what I was thinking, the way I like to read buttons is take an initial reading, wait a small period of time, take a second reading, and then you can tell if the button changes from like a high reading to a low reading, it's been pressed. Or if it changes from a low reading to a high reading, it's been released. That way I don't need to look at, because if I just looked at like, is it at a low level, is it being pressed? Then as long as I'm pressing the button, that's going to be true. And I'll just fly through this array of colors constantly, which I don't want to do. I really just want to detect the transition of when I release my finger from the button, then change to the next color in this list here. So I think the easiest way to do that in this sketch is to actually take that reading right before I show the pixels and right after I show the pixels, because most of the time in the sketch is going to be spent right here. And it's not really obvious, unfortunately. You kind of have to, learn a little bit about what's happening behind the scenes here. But this strip.show actually sends out that special signal to light up the pixels. And then the delay is just literally the processor is in a loop for 50 milliseconds waiting to finish, and then your code continues on. The rest of this code is just doing a little bit of light math, changing some values in memory, and that's it. That stuff happens really quickly. The processor can do that in just a few cycles. So really most of my time is going to be spent here. And so it makes sense. If I take an initial reading at the start and then a second reading at the end, that should be good enough to detect, when someone presses the button, that, we'll be able to catch that. So, okay, let's just do an integer. We'll say the first reading equals digital read button. And then my second reading equals digital read button. So, okay, so that's cool. And then let's just put in the logic. So check if the button was released, then change the color. So let's just see. So when the button's released, so normally the button's at a high logic level because it has the pull-up resistor. So if it's been pressed, it's going to go down to a low logic level. It's because it's connected to ground. So that basically means if it's not first, so if my initial reading is at a low logic level, and then if my second reading is at a high logic level, then I know it's been released at that moment in time. So if not first and second, which basically means if my first reading is false and my second reading is true, then go through this block, like consider the button pressed at this, or released rather at this point. So it kind of helps maybe sometimes to think about the digital logic here and how things work. And unfortunately, when you use input pull-up, it kind of changes. Intuitively, you might think like when the button's pressed, it should be at a high logic level, but that's just not the way it works. And I don't think Arduinos have pull-down resistors internally. I think it's just pull-ups that you get. The Raspberry Pi does have pull-down resistors, which is kind of nice and handy to do. So okay, so this means this code should run whenever the button's released. So at this point then, I need to also keep track of my color index. How about? So this is just going to point to which color inside of this list am I currently using. So when the button's pressed, I really just want to increment this. So we'll say color index plus equals 1. And then I want to check and see if I get past the end of the color list, I want to wrap back to the beginning here. And so there are a couple ways you can do this. I'll just be explicit with an if check. You can be clever and you can use the modulus operator to say, okay, maybe I want a modulo color index, or actually here I could say like equals color index plus 1, and then modulo this whole thing, because modulus, it gives you the remainder after integer division. And if you think about it, if you kind of sit down and do some of the math, it's a good way to constrain an increasing value to a smaller set of values. But I don't like when you see that in the code, it's not as obvious. Like, yeah, you can get it down to like a one-liner. So like I could do size of my colors list divided by the size of uint32t. So, this would work, but you look at this and it's like, what's going on here? So I like keeping it simple and keeping it explicit. It's kind of an if style logic here. Lots of schools of thought here. I think this sketch is small enough that it's not so bad to have a little bit extra code for this. Performance wise, it's not going to matter. Like, sure, the modulo version might be a teeny bit faster, but this is like nanoseconds that we're caring about. So okay, so if color index is greater than the end of the array, so how do you figure out the end of the array? So you could know, I could just have a define ahead of time. I could say like, okay, how about define number of colors, and this could be 4, let's say, because I've got 4 colors in here, and I could even use that to set the size of my array here. And then now I need to be careful every time I add a new color to the end. I need to bump up this num colors over here, but then it's kind of handy in that I can also use num colors down here. But I'm not going to do that. I'll show you another way that you can do this. You can basically look at the size of this list in memory. So the size of function is a really handy C and C++ function. You point it at a variable and it gives you the size of that variable. So it's going to tell you, for this variable, it's on the stack, it's a list of colors, it's an array. So it's going to actually give me the number of bytes that this array takes up. And so each entry in this array is 32 bits long, so that's 4 bytes. And I have 4 entries in here, so this should be 16 bytes total that I get back. Now, just knowing the number of bytes, that doesn't tell me the number of things in here, because each thing in here is 4 bytes long. So if I take the total number of bytes of this array and then divide that by the size of each individual thing in the array, that will tell me the number of things in this array, like 4. And so that's what I want to do here. So I'll just do the size of my color array divided by the size of a thing in the array. You could do like the 0th instance here. I think this is a pretty common pattern that a lot of people do. So this is going to look at, okay, what is the first thing in this array, and then what's the size of that thing, and it's going to see that that's a uint32 and that's 4 bytes long. But I don't know, I'm going to be more explicit here, because then you have to kind of be careful, like what if you have nothing in this array, then and you try and take the size of item 0. I'm not sure, maybe that works, maybe you get some fun problems. So I'll be explicit here and do this. Okay, so if we are greater than the size of our array, then basically we've gone past the end of it. And actually I want to be careful here if I'm greater than or equal to the size of my array, because once, remember, the arrays are indexed by 0, so even though I have 4 items in the array, so the size of this array is 4, the last item is element 3, because it's 0, 1, 2, 3. So once I get past 4, so once I increment past 3 to 4, then I've gone past the list, the size of the array. So then at that point, I want to reset my color index back to 0, like this. So that's how I kind of like to do this check, because then it's a little more explicit. I can even say, like, make sure the color index wraps back to the start. Okay, so that's cool. So I'm changing the color index. So we're pretty close here. Now the only thing I need to change is just how I set the colors here. So I know for sure the center color I'm going to choose as my colors color index. So that's going to pick your main bright color here. And just to get started, before I do any extra logic, let's just have it light up the other colors, the other 2 pixels with the same color, so that I can at least check and see that the color changing and button stuff works. And then let's look at maybe dimming these pixels down a little bit. So okay, so let's save that. Let's make sure that compiles. And then, okay, so I got something wrong. Oh, so colors, it's not color. It's basically the name that I misplaced there. So okay, so save that. And then compile that. Oh, and I got something wrong here. I'm probably missing a parenthesis, it looks like. Yeah, so save that. And check that. Okay, so that compiles. So let's upload it. And we'll press upload. It's doing its thing. So, okay, cool. So notice it's a little more of an orange color. It's probably hard to tell on the camera, but it's definitely more orange. It's animating, so that's good. I didn't break anything in the loop. Now let's see what happens. I'm going to press the button a little bit, and let's see what happens here when I press this. Hey, look at that. It turned green. And then I press it again, and now it's like a kind of like a bluish green color. And I press it, and now it's like a blue color. and then I press it and it goes back to orange. So let's just double check. If I do 4 presses, I should get back to orange. So 1, 2, 3, 4, oh, 5 presses, sorry, 5. There we go. So, now I'm back to the start. So that's cool. So it looks like, we're going through the colors that I have here. So nice. All right. So let's go on and let's see if we can dim these colors a little bit. And let's see what I was thinking for this. Okay. So basically, before I draw my pixels, let's define kind of my bright color and my dim color, and then I'll use those to set the colors. So we'll say uint32t, we'll say the bright color. This one's easy. It's, the color that I'm pointing to in my index here. And then maybe we'll say the dark color is what I want to set next. And so let's just set that to bright initially. And now I want to go through and I basically want to take like the red component and scale that by something, like divide it by like, I don't know, maybe like 30% or something like that. So it's a little bit less bright. And then I want to, do the same for the blue component. I don't want to divide the whole value by that because it's really these individual components that I need to go through and change. And actually, you know what I could do? How about let's just pull out all those components. So let's do the red component of this bright color. That's going to equal the top 8 bits. So I need to get rid of the lower 16 bits here. So if I drop those, because there's 2 bytes that I want to get rid of. So I'm going to bit shift it over 16 positions. So that's going to give me, this top position is now going to be in the bottom position down here. So, okay, so let's do that. And then let's just AND that by OXFF. So this is just only going to strip out the lower byte, which should be okay because there's nothing above this byte, but just in case I want to strip it out and make sure that I don't see anything there. And then let's do the same thing for green. So the green components is going to be bright. Now shifted only by 8 because I just want to get to this this byte, and so I need to shift over these bits to get to this one in the lower position, that middle one. And then same thing, and I really do have to AND this one by OXFF now because this is just going to strip out. It's only going to give me that lower byte in this case. And then the blue one's really easy. So the blue component, I can just, it's already in the lowest position. So if I just AND it by OXFF, I'll get that component in this case. So let's just do bright ANDed by OXFF. Okay, so now I know the red, green, blue components of the bright color. Now I can create my dark color. So let's say my uint32 dark. Okay, so let's just kind of build this thing up in a couple of steps. So like I said, I'm going to scale this, and maybe let's make it define. So we'll say like dark scale. What do I want to divide this thing by? I could divide it by 2 to like cut it in half. Divide it by 3 to cut it into like a third maybe. Let's try that. If I make it a define up here, then I can play with it more and tweak things. So okay, so let's take my red divided by my dark scaling, and that's going to be my new red value for this. And so I want to shift this over. Well, let's you know what? Let's build this out into, let's go step by step with this, because if I jam this all into one line, it might be a little weird and hard to follow. So we'll say dark red equals my my bright red, and here let's even be explicit. How about bright red in front of all of these? So bright red, bright green, bright blue, and so now I want to take my bright red, and divide it by my dark scaling. So this is basically going to cut my my bright red value right now by 3. So like take a third of it. Maybe I could go to like 2 for like half of it. It's going to make it less intense effectively. So same exact thing for the green value. Let's say dark green. So let's take my bright green divided by my dark scale, and same thing for my dark blue divided by dark scale. Okay, cool. So now I've got the color components for my dark color. Now let's reassemble them into the dark color. So my dark color, so now I need to take that dark red component and I want to basically, I'm gonna just grab the low byte from it. I don't need to do this, but it's smart, I think, just to, I know that I only want this lower byte. Like, it is a uint8. Well, I guess I don't really need to do it since it is a uint8. There's no way this thing's going to be bigger than a byte. Okay, so that should be okay. Now, if I shift it over 16 positions, now that low byte is going to be in this upper position here, and then the rest of this is just going to be zeros. Like when it bit shifts, it just adds zeros onto the end there when it doesn't have any data. So that's fine. Now, if I do a Boolean and, then that's going to basically append these two different values together. So if I take my green component and I shift this guy by 8, and then I also take my my blue component here, and I don't have to shift it at all because it's already at the bottom. By doing this Boolean and, it's basically taking, okay, grab this high byte and then add whatever the next lower bytes are to it, and then add the next lower bytes below that. You can actually use addition for this also. You can go either way with this, but I'm just going to do the Boolean AND operation here for this. So, okay, so, or sorry, this is not OR, this is OR. So yeah, scratch that. This would be AND. That would not work. I want an OR operation now, because if you think of the order of operations, so like, or the Boolean truth table, 0 or 0 equals 0. So if I have like a 0 in a low bit here and a 0 in a low bit here, it's going to be a 0 in the final thing. But 0 or 1 equals 1, and that's what I want, because my low bits here are going to be 0, and then these are going to shift over, and they might have some 1s. And so that's okay, because 1 or the 0 in the low bits up here is still going to equal 1. And even if I get 1 or 1, that's still going to equal 1 in the final output here. So, if you get confused, go through and kind of look at like the truth tables of things. But it's the OR operation that you want here. So, okay, so save that. Okay, now I've got my dark and my bright pixels. So I think I can just change these, and we'll just say I want my dark pixels on the end, and then my bright pixel in the center here. So in theory, and I haven't done this before, so hey, you might be watching me do some fun bugs and things live here. So let's see, okay, let's upload this. And I'm not totally sure how this effect is gonna look, if it's gonna work or not, but hey, we'll see what happens. So, okay. Oh, interesting. Okay, yeah, so it's definitely changed it. So you can see, it's hard to see. So the center pixel is definitely the main color that I had. The outer pixels, they're a little bit, they're whiter than I expected. So it's interesting. I wonder if I've gotten some of my math or my operations wrong. I'm going to press the button and let's see how things change as I go through the pixel colors here. So interesting, yeah. So this one is blue. Oh, I think I kind of know why. So it's kind of green in the center and it's blue towards the edges on this one. And then I'm going through the different colors here. So this one actually works. This one's mostly blue and then less blue on the outsides there. So I think kind of what's happening here is because I have a little bit of color here, I'm dividing this by a third. And so that's giving me, a less intense color, but there's still some color there. Let's just go like pure red, pure green, pure blue, and see how this looks. And actually, I'll just pull this guy off the end there too. And that's the nice thing. I don't need to change like the size of this array. It's going to just automatically figure out that there's only 3 things in here. So let's see how this looks. This really should, like, I should only see red, I should only see blue, I should only see green colors here, as long as I got all this math and stuff right here. So, hey, no one's perfect, so I might have gotten some fun stuff wrong there. But let's just see what happens with this. And so now, okay, that's looking a lot better. And you know what? Let's stop the animation so that we can just look at these colors in isolation. So let's just hard code in right here. Let's say my position equals, how about 3? That'll put it kind of in the middle, or maybe 4, we'll say for that. So, okay, let's do that. And then that way I can just look at what are the colors here. So let's do that. And then upload this. And it does its thing. And so now we can kind of see, okay, so you really can only see red, and then I'm dividing by 3, and I don't even see any of the other colors because maybe I'm just dividing them too much to see much in there. So let's divide by 2 and see if we get a little more intensity in there. So let's save that. And I'm really curious if those other pixels are lit up or not. But let's see, because I should see some color, although the shades themselves block a little bit of the light. So, you know, I'm not totally confident that I've got all of the math right here, though. I don't feel good about this yet. So let's just see. And the other thing I could do, if I really wanted to, I could hook up some of the serial outputs that I could see. Oh, no, duh, I know. Oh, no, this should be okay. Yeah, that should be fine. Interesting. So, yeah, I don't know why the dark color, I really don't see much of it here. So let's just kind of go through and debug some of this as I look at this. So, and I'm trying to think of a good way to debug this without having to hook up the serial cable here, because I want to know, do I have this math right? Am I getting the right colors? You know, am I getting the right red color here? For this. So, you know, I should be getting the right values for this, but you never really know until you check for sure. So, so if I get this bright red color, you know, this should be OXFF for red, and green and blue should be 0 in these cases. And then I'm going to divide this by my scaling factor, which is 2. So this should go down to like OX1, you know, like 128. This should go half the color effectively. In this case. And then when I reassemble this, it should go back to, you know, the red component should get sent back to the red part of it here. So I'm not totally confident that this is working as I expect this. So let's just see, you know, I could light up a pixel if I see a value that I expect here. But, you know, that might be too much of a pain to debug. You know, maybe I'm going to leave it for now. Maybe I'll do that off the stream because the stream's already running kind of long. So, you know, this is maybe part 1 of optimizing this sketch. We at least saw how we can add the button, but I'm not totally confident in this animation just yet. I mean, the animation works, like it's changing the colors, but I don't trust my my math here just yet. Like this scaling that I'm applying to it. So, or maybe it's I just noticed a bug in this. I'm using green right here instead of blue, so that could be some of my problem here, although it certainly wouldn't be my problem with the red colors here. So let's just save that and let's see what happens. And yeah, I fixed up the pixel there, so it's going to animate. So let's see. This is kind of the problem when you start to, you know, debug things. Really easy to make a little error like I just made there. And then it's like, you know, unless you can start looking at those values, it's hard to know, like, you know, is it really wrong? Like just by looking at it. Okay, so that makes sense. So yeah, I don't see that weird little like kind of white on the end that we saw before. Although actually I changed the colors here. So, but let's just go through and let's just press this and double check that, you know, okay, yeah, so there's green. And green definitely looks like it's scaling. I see multiple greens lit up in this case. And then blue, yeah, blue looks like it's working. So interesting that with red, it's not lighting up the way that I expect. So that's telling me that there's something up with the red color that I'm setting here. So I'll give this just one more second chance here to see if I see anything super obvious. You know, basically I'm taking my bright color and I'm shifting it by 16 bits over. Which should be okay. You know, that should give me this value right here. And then I'm just grabbing that lower byte for it. And then here I'm just dividing it by the scale. So it looks like it's okay to me. But like I said, I'm going to come back later and double check that because I just don't trust this. It doesn't look correct to me. But hey, it does work. So I've got a button here and I can add all kinds of colors and things to it. And, you know, I press the color and it cycles through, you know, the different colors here. So that's pretty cool. So let me pull these off and we'll we'll give it the final kind of look here. And if you have questions, you know, throw them in the chat. I was thinking, yeah, rainbow might be a neat color to add to these. So, okay, let me plug in the battery for this also and see. All right, get that in. And then, there we go. All right, nice. There's that. Let's see. Let's jump back to the main kind of headshot view here. Do that. Okay, cool. That's kind of fun. So, all right. So there's that. And now if I find the switch over here, so it's kind of got to feel where I put it, and the battery cable kind of covers it up a little bit. So there we go. Okay, so press it. Hey, look at that green mode. Press it again, blue mode. Press it, red mode. So that's pretty cool. You know, go through all the colors. And it's just as easy as going in and changing the colors in the sketch. So, you know, I can just add extra colors. I can remove colors. And then the scaling logic, as you saw, I'm going to revisit that a little bit and see kind of what's up. Pretty sure I've got some kind of bug in there in the logic. But, you know, it's just my kind of first blush at how to scale these lights. It's just a simple thing, you know, just divide it. I could like maybe get more advanced and try and scale it in different ways. But I think, you know, keep it simple here in this case. So cool. All right, I'm going to put these up so I can actually see the comments here. So if people have questions, throw them into the chat here. And yeah, I don't see many questions. So yeah, that's it. That's basically the second part of the Larson scanner shade build. So these are cool kind of cyborg shades. Check that out. So that's pretty fun. And then I've got the button here. So if I want to press the button, then I can change the colors, cycle through different things. So pretty cool. I think this will be fun. This is a good little demonstration of, you know, the Gemma and the NeoPixel strip inside of here, and just real kind of basic project, but you can do a lot of things with this. And if you add a button, you could get even more advanced. I could change the animations instead of changing the colors. You know, if I wanted to maybe have it do more than just move side to side, like maybe like start pulsing or fading or things like that. Sky's the limit as far as what you want to do with this. So that's it. So I think I'll wrap up the stream. Subscribe to twitch.tv/Adafruit. You can watch me stream this stuff live. YouTube.com/Adafruit. I put up all these videos. We have all kinds of other fun project videos there. I like to stream a couple times every week. So Mondays I'll do a little Raspberry Pi quick look at some interesting software. Yesterday I looked at Node-RED, which is a neat little visual programming environment for the Raspberry Pi that's based on Node.js. So just looked at kind of what's the basics of it. And then Fridays I like to do more in-depth kind of Raspberry Pi programming stream. I've just done a 2-part series so far on using SQLite to store sensor reading data. And I think I'm going to continue that. I think there's at least a few more parts to do with that one. But this Friday I'll actually be gone. I won't have a live stream. I'll be out at tour camp in Washington. So that's kind of why I wanted to get these fun glasses for that. So no live stream this Friday, but then next week I'll be back to the kind of the normal schedule of Mondays and Fridays, and starting to do more than that too. I'm hoping to maybe do some Circuit Playground streams again too. So kind of keep tuned in and check out all the fun stuff that we got. So this is Tony from Adafruit, and thanks for watching the Larson scanner software enhancement build.